Okay, we're going to continue on with part 4. And I actually now realize that I put my end of part 3 in the wrong place, and I've got 2 more slides still dealing with Bernoulli's principle, and we'll go on to plasmas after this. But so let's finish up. Let me dismiss this, and this is still on Bernoulli's principle. On a windy day, waves in a lake or the ocean are higher than their average height. What factor in Bernoulli's principle contributes to the increased height? A, reduced pressure pulls water upward. B, pressure builds up over the crest. C, air travels faster over the crest than the troughs. Or D, none of the above. Well, it's actually C. The air travels faster over the crest than the troughs. The troughs of the waves are partially shielded from the wind. So air travels faster over the crest. The pressure there is thus lower than down below it in the troughs. The greater pressure in the troughs pushes water into the even higher crest. And they have a image of this in your textbook. I didn't include it in the lecture, but that's the answer. Now that we're going to plasmas. Plasma is the fourth state of matter after solids, liquids, and gases. There is a plasma. Plasma is an electrified gas. The atoms that make it up are ionized, strip of one or more electrons with a corresponding number of free electrons. The plasmas are the least abundant in our immediate environment, but the sun and other stars contain plasma. So they're pretty prevalent in the universe, but here on the Earth, they're not that. We don't see them. I mean, you'll see examples of it in your lighting, the fluorescent lights. But it's prevalent in the universe, just rare on the Earth. I think I skipped a slide. Okay, sun and other stars contain plasma. The aurora borealis and the aurora australis, the northern lights and the southern lights, are glowing plasmas in the upper atmosphere. The sun puts out energetic particles that come towards the Earth. They get caught into the magnetic field in what we call the drift, the V cross B drift, sends them to both the North Pole and the South Pole along the Van Allen belts, and you get these beautiful glowing sheets that make up the aurora, and those are plasmas. There's layers of low temperature plasma encircle the whole Earth. Occasionally, showers of electrons from outer space and radiation belts enter magnetic windows near the Earth's poles, crashing into the layers of plasma and producing light. This is what we call the aurora australis and the aurora borealis. I've never seen one. I hope to see one. It's on my bucket list, but you can't really predict when they'll occur, so it's just kind of a thing of chance. Okay, fluorescent lamps and neon lights. When you turn the lamp on, a high voltage between electrodes of the tube causes the electrons to flow. These electrons ionize some atoms, forming plasma. The plasma provides a conducting path that keeps the current flowing. The current activates some mercury ions, causing them to emit ultraviolet radiation. This radiation causes the phosphor coating on the tube's inner surface to glow with visible light. That's how fluorescent lamps work. The plasma screen TVs, flat plasma TV screens, are composed of many thousands of pixels. Each has 3 separate cells of red, green, and blue, each containing a different gas. Pixels are sandwiched between a network of electrodes. The electrodes are charged to produce electric currents flowing through the cells. Gases convert to glowing plasmas, releasing ultraviolet light to simulate the phosphors. The image on the screen is the blend of the pixel colors activated by the TV control signal. Plasma power, and I think this is the last slide in the lecture. A high temperature plasma is the exhaust of a jet engine, a weakly ionized plasma. When small amounts of potassium salts or cesium metal are added, it becomes a very good conductor. When directed into a magnet, it can generate electricity, magnetohydrodynamic power, MHD. Low pollution MHD power is in operation at a few places in the world already. And I believe that is the end of the chapter 14. And we'll end it here.